is Shifumi and I'll be your physics tutor. So today we'll be talking about motion. So our topic for today will be motion, and here is our course outline. So our course outline should be introduction to motion, type of motion, the terms used in motion, which is displacement and distance, speed and velocity, acceleration and what. So we have the equations of what motion. Now, so now what is motion? Motion is the change in position of an object with time relative to a reference point. An object is said to be in motion if its position changes with what time. Now, let me take this as an instance. I am moving from one place to another. It is what it's called what motion. A ball moving from one place to another, it is an example of motion. Or any object, it's saying that any object that is that the position has been changed is called a what. So it is said to be in what motion. Now we have types of motion, which is the first type of motion is the translational motion. So the translational motion is when an object moves from one place towards another. So example, we have a moving train. So a moving train is moving from, so the objective of a moving train is for it to move from one place to another, which is going from places to places. So we also have a rolling football. So a rolling football objective is also a what translational motion because it is moving from one place to another. We also have other example from like a boy walking to school. So is on a what translational motion. Now the second type of motion is the rotational motion. The rotational motion occurs when an object moves about its own what axis, when something rotates, like a spinning top, a spinning top, or a blade of. So let's use the blade of a fan as an example. The blade of a fan moves in a what rotational motion because it is moving on its own what axis, rotating. So let's move on to the third one. So the third one is the oscillatory motion. So this is a repeated through and fro motion about a what fixed point. So when something is moving through and fro, like moving left and what moving right. So example, we have a what a swinging pendulum. So a swinging pendulum but moving from left to right. It is an example of what oscillatory motion. And we have a vibrating guitar, a vibrating guitar string. So it is also an example of an oscillatory motion. Now we also have, we also have a swing moving. A swing also moves in an oscillatory motion, moving front and what back. It's just like the single pendulum moving left and right. Now, so we have the fourth type of motion, which is the random motion. The random motion is said to be a motion without a what definite path or direction. Example is the movement of gas molecules. So when there is gas field, you will see that like when you check the movement of gases, they don't just stay in one place, they move all around without a what definite direction they are going to. So we have a flying mosquito, yes, that one too. So what they do is perch and what move to another what direction. They don't have a definite what, they just move all around. So we also have the butterfly movements. So it moves, you see it moves like this. So it doesn't have what definite what paths. It is not going straight, it's not going all around, it's just going anywhere it wants to. Now let's move to the terms used in motion. So the first term is the distance. We have the displacement, we have the speed, and we have the acceleration. Now let's look at distance and displacement. Now, what is distance? Distance is the total length of the path covered by the moving object. Let me say I am going to my school. So the distance covered, the distance covered, like it is the total length covered within me, like within me going to my school, is called what? Distance. Now, we have the characteristics of distance. It is a scalar quantity, as it has magnitude only, and it is measured in what? Meters. So displacement is the shortest distance between the initial and final position of an object in a specific what? Direction. So it is a vector quantity, it has magnitude and direction, and it is also measured in what? Meters. So both displacement and distance are similar. So it's just that one has its direction. Now, let's move to the next one, speed. Speed is the rate at which distance is covered. So as I've used me going to my school, it is now the speed of me, the rate of me, in which the distance is covered. Hope you get, which is the time at which the distance is covered. So it is measured in so the formula for it is speed equals to what? Distance over time. We all know that. And the SI unit is meter per seconds. So let's move to the next one, acceleration. Acceleration is the rate of change in velocity. It is the rate of change in velocity, and formula for it is acceleration equals to velocity, initial velocity over final velocity over what's the time taken. So that's what we use in calculating acceleration. So now guys, so we have the equations of what? Motion. Now the first equation of motion relates velocity, acceleration and time together, which gives the formula v equals to u plus at, where v is the final velocity, u is the initial velocity, and a is acceleration, and t is the time. The final velocity of an object is equal to the initial plus the product of acceleration and time. Yes. So according to the formula, it says what the initial velocity, it is the final velocity is equal to the initial velocity added with the what? Product of what? Acceleration and time together. So that's how we find the first equation of motion. So let's move to the second equation of motion. So the second equation of motion relates to with the displacement, initial velocity, acceleration and what? Time. So displacement is said to be the s equals to. So the second equation of motion is said to be the what? S equals to u plus 1 over 2 at square, where s is the distance traveled in time, u is the initial velocity, t is the time, and a is the what? Acceleration of the body of the motion. Now we have the last equation of motion, which relates velocity, acceleration and displacement together, which is what? V square equals to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. Now for the three equations, note that the first equation is v equals to u plus at. Now the second equation is s equals to what? Ut plus 1 over 2 at squared. Then the third equation of motion is what is given by the formula of v square equals to u square plus what? 2as. Please take note of that. Now, so on our next class, we'll be taking more on this. We'll be looking at the examples, how to solve those examples given by the equation of motion. Thank you for watching. See you in the next video.